Welcome back once again. How do we get online? How are we connected through this Zoom? And when we visit websites, how is it that from my computer, I'm able to reach a website on a different computer? And the very servers that basically connects us through Zoom. So folks, let's see what we talked about last time. We looked at the core pillars of IT. That's fine, then don't worry. I can choose any username I want. That's not a big deal. Okay. And the core hardware in IT is the compute, the servers, the network, and the storage. In our previous two sessions, we looked at the hardware, specifically the servers. We looked at what's inside the server, the different components, the CPU, the RAM, the hard drive, the motherboard, the PCI slots, the networking card. Okay. And second thing, we talked about what their role is. CPU is the brain of the computer. RAM is the temporary storage. Motherboard is where everything gets connected. Power supply powers the server. Storage stores the data permanently. GPUs do graphical processing unit, and network cards take the packets from your computer to this computer, from this computer to the next computer. Okay. And the cooling systems, the fans, take care of the heat in the system. All right. Now, again, those are the same components. Today, I want to bring your attention to the networking, basics of networking. How's the networking done? What are the different components of the networking elements? But before we get into that, if everybody is on a command line, which I am right now, on the command line, I want to refresh your memory and I want to check your knowledge. You will tell me how long the server has been up and running. Go ahead and type the command. Excellent. The server has been up and running for 7 days, 6 hours and 44 seconds, and there are 220 users logged in right now. And this is the load average on your server. The load average intervals are 1 minute, 5 minutes, and 15 minutes. Okay. And I'm going to type the command to see how many people are logged in over here. And right over here, I see 222 users are logged in. And this is what I see over here. Next thing I want you guys to tell me is how do you check the CPU number of cores on your server? lscpu. Okay. Please keep your cell phone mute, and lscpu will show you. Now refresh my memory. What is the CPU socket? What's the CPU socket? That's the one physical processor, one physical socket. And then physical sockets have what? Well, CPU sockets have what inside of them? They have cores. And then if you want more cores, what is that technology that gives you more logical processors? Hyper-threading. So each core can be hyper-threading, can have multi-threading, and you multiply that core with 2. If you have a one physical processor, and then there are 8 or 16 logical cores in there, and they are hyper-threaded, then you have 32 processors. Excellent. I want you guys to help me with the amount of RAM in this server. Amount of RAM in this server. How much RAM do we have in this server? What's the command for that? free-h. I have 755 gigabyte in this machine. Okay, great. We're going to talk all about networking, how servers talk to each other. What are the main components in the networking? And therefore, I need to show you, first of all, we have these 3 servers. I got myself one 1U server, one 2U server over here, right? And then I have another 1U server. I talked about these servers last time, right? And now we're going to see the back of these servers and we're going to try to network them. There are 2 things I want you to know before we get into the core networking. There are main components of the networking. Let me share my screen over here one more time. So to begin with, we have computers on the network. We have printers. Let's take a look at what is found in the enterprise environment. You have people connecting their laptops. You have people connecting their desktops. You have people connecting your servers that sit in the data center, servers like these, the ones that we have over here. These are data center grade servers. And we talked about it specifically. These servers sit in the racks, and there are thousands of racks, depending on the size of the company. If you are a Fortune 100, 500 company, you have thousands of these babies sitting in your racks. The reality is today, me and you communicating over Zoom, the information is being processed by these babies at the back end. These are the very servers that are processing this request, this video and the Zoom request. And that's why we're able to communicate. The information is flowing through these servers. So the things that you're learning, it's very, very fundamental. And so these skills are going to stay no matter what happens, no matter AI takes over the whole universe. You're still going to have bare metal servers. You still need to be working with these people, with these servers. You need people who understand these bare metal servers. And Linux skills is going to grow. And the demand for Linux professionals is going to grow exponentially because the data centers are going to grow. Therefore, number of servers are going to grow. Therefore, those people who manage these servers is going to grow. So when we talk about networking, we talk about equipment being on the network. Being on the network means devices able to communicate with each other, able to send packets to each other. Like me and you were able to communicate through a network. We are communicating over a WAN network. So when you walk into an enterprise environment, a company where you work as a system engineer, as a help desk technician, or whatever your role is, you will see devices like laptops, desktops, printers, servers. You will see switches on the network. You will see routers on the network. And you will see firewalls on the network. And most importantly, you will see a lot of servers on your network. So, how these devices connect with each other and how do they communicate? That's our topic today. So, to begin with, you have your laptop and desktop. And the next element that you need to understand is basically the switch. Switch is a device where all of your computer servers get connected. Your printer, laptop, your desktop, your server, they all at the end of the day get connected to a switch. Let me show you the switch over here. This is an enterprise grade switch. Haris, maybe you can come over here close by. So folks, this is the switch that I'm talking about. In every enterprise, cannot see anything. What do you mean by you cannot see anything? I stopped sharing my PowerPoint and now I only have my video, okay? So the switch over here is the main element in the networking. Our focus in this class is to learn about the enterprise networking and the server management to become a Linux admin, Linux engineer, DevOps engineer, and eventually become an AI infrastructure engineer. We're starting with the physical layer, and the physical layer is basically the bare metal servers. We looked in the inside of the server. Today, we're going to talk about how do we connect these servers to a networking switch, and how does that switch get connected to the router, and what each one of these components do. So let's say you have this physical server over here. You would install your operating system on this. So this would give a life to a server, okay? And then this server, you would take a RJ45 cable, which is one right over here I have. This is basically the RJ45 cable. So this is the RJ45 cable right now, folks, that you can see. This is also called the Cat 5 or Cat 6, category 5 and 6. Basically, it has to do with the speed. Both ends, one end of your computer where you have your network card. Let me show you your network card. Right over here is your network card. This right here is your network card right here. So we would plug one side of this cable into your network card. Let me just flip this over here so you guys can see this in more clarity. And basically, I'm going to plug it into one of these guys over here. So now, one of our network card is connected. One side is connected. The other side needs to be connected to the switch. So let me put this over here. And now I'm going to bring the switch over here, and I will basically be plugging into one of these cables over here, one of these ports over here. There are 48 ports on this switch. Now you have a server which is connected to the switch. So let's talk about the role of the switch. What does a switch do? So we just did one server, right? And if I wanted to bring this server on the network, what would I have to do? Well, same thing. I would have to take a cable, plug it into this machine's network card, and then plug it into the switch. If I want to put this server online, same thing. I would take a cable, I will insert the cable into the network card and connect the other side into the switch. So why don't we do this while we're at this? Haris, you want to help me?
Yeah.
Inserting this into the interface. Show me in right over here in this server.
This sir.
Server's port, network port. That's the iDRAC. Yeah. So look for the Ethernet port. You want to look for the Ethernet port. All right.
Yeah.
It's connected. All right. Very good. All right. Excellent. By the way, Haris is one of my students from 2025 batch. And I want to congratulate him. He just got his offer from a company based in California, work from home. And Haris, why don't you come over here?
Sure.
Sit down over here. And while I'm going to make sure that connectivity is correct,
Cool.
Share your story with my students. How did you get? How has the journey been so far?
Yeah, definitely.
Just hold on.
Yeah, okay.
Yeah,
So can everyone can hear me?
they can hear you.
You can hear me? Sure. Hey everyone, my name is Harris. I actually joined Lanoop last year. So when I joined Lanoop, I was in the same situation as all of you are right now. I did not know anything about Linux. So when I joined Lanoop, I did not know anything about lscpu command. I did not know about uptime command. I did not know about pwd cd command, none of that. So as I was learning and what I was learning, I was spending a lot of time outside of what Asadbai was teaching. So in my case, I was spending about 1 to 2 hours outside of just these classes, and I was adapting, and everything Asadbai was teaching, I was just practicing on my own every day for 1 to 2 hours. So what that enabled me to do was that it actually, now that I recently was in the just some of the application process. What that enabled me to do was I was able to take a lot of the interviews, and a lot of the interviews that I was going to, they were actually asking me all the same commands that I learned throughout the course. So in 6 months, like I went from knowing nothing to like knowing a lot that I could have never imagined myself knowing, like just some of the troubleshooting, some of the finding the root cause analysis, some of the incident response, some of the troubleshooting, automation with Ansible, updating and upgrading just containers with Docker, and orchestrating those with Kubernetes. So Asabai and the team actually enabled me to do all that. Taught me hands-on learning for 6 months, and and I recently also became Red Hat Certified System Administrator. So that was also, yeah, so I am also a Red Hat Certified System Administrator, and I will be planning on taking my RHCE, which is the next step in the process. So, so all thanks to us, Sabai. So it's just you have to really dedicate yourself to the process. Just trust Asabai and the team, and then you will eventually get there. Like I just secured an offer, like Asabai was mentioning, at one of the companies in California. So I am right now working from home. So, it's been great. And I never really thought that I would be able to get there. And it's funny because I did not come from an IT background. So I had a bachelor's of science in biology. So, so it's funny, how my life was very atypical and just transitioning to IT over time. And all props to Asabai and the team, honestly. So yeah, thank you so much for having me, Asabai. Appreciate it.
Thank you. Thank you, Haris. Thank you so much. God bless you. You're a smart guy. You're a hardworking guy, and that's what gets the job done, honestly speaking. And you believed in yourself, you believed in your creator, and you worked hard. And that's all is there, honestly speaking, in order for you to become successful. Okay, so there will be some online classes toward the middle and the end when we prepare you guys for the interviews. Then we had some students over here. That's why Haris was here too. They were playing with the bare metal servers and practicing for the interviews. And so we'll talk about that. Okay. Give me your attention for next 20 to 30 minutes. I know it's very difficult for you guys with the distractions that you have on your cell phone and the TikTok and the Instagram, but believe me, I'm here to teach you something and make it valuable for yourself. And don't make me feel like I am wasting my time over here. Okay. Stay with me. These are very fundamental concepts. And if you don't understand them, you're going to suffer for the rest of your life. Okay. I want you guys to get straight these concepts, get them straight right now. So to begin with, we have servers. We have a bunch of servers over here. We want them to talk to each other. We want them to communicate with each other. How are we going to do that? We need a switch. We need a connector in between them. So all of these servers, they get connected into the switch. One side of the RJ45 goes into the port on the switch, and the other side goes into the network port on the server itself. You guys are able to see this? Does this make sense to you guys? So this is physical stuff. This is how things get done at the enterprise level as well. Home level is a little bit different because you guys are using your Wi-Fi signals to communicate, but you have a wireless card, and then there's a wireless router at your home. But in the enterprise, with the enterprise companies, Fortune 100, 500 companies, this is how things get done. Servers do not use the Wi-Fi signals because they need reliability. So therefore, here you have a switch over here. Let's talk about the job of the switch. We understand what is server. Server basically serves a purpose. It's a role on the network. I install Linux on this machine. You guys all logged into my Linux server. You're running the commands. So this is basically user server. You come over here to learn. So this is purpose serving a purpose. You all connect to that server. Now at work, in the enterprise environment, there are different type of servers. One server could be a data server. One server could be a file server. One server could be user management server. Another server could be a documentation server, which is running a website. There are application servers. For example, when you guys click on your Instagram, TikTok, or whatever social media, Facebook, you're also connecting to some application server. Same servers that you're seeing over here in the data center. Okay. So we understand the servers. The next part is understanding this networking device. This is called switch. What is switch job? Switch basically is a core networking element. It's a networking device. It connects two machines together. Whenever you want one or two machines to talk to each other, they need to be connected to the switch. They need to be connected to the switch. Doesn't matter where the switch is. Maybe in one building, another building, they need to be connected to the switch in order to be connected to the internet. And then there are different type of networks. There's a LAN network, there's a WAN network. LAN network is that I have this building over here or this area over here, and I want to connect all the physical servers that are in this building over here to the network that's in this building. All I need is just the one switch. And I connect all of those devices into this switch. Now I have a network. Now, I have a network over here. These three servers are on the network. If they had an operating system and if I were to turn them on, all I have to give them is IP addresses, and they will be able to talk to each other. They will be able to communicate with each other. They will be able to share files. You will be able to log in from this server to this server. Just like you guys were able to log in from your home into the Linux OS, Linux server to run your commands. So far so good. Are you guys with me? I feel like today my students are not connecting with me for some reason. Maybe the networking hiccup. Some of you guys are built this way that if one thing doesn't go right, you're just focused on that. You're not going to let it go. Oh my God, it's not working for me. What am I going to do with my life? Nothing works for me. Stop, okay? Stop panicking. It's okay. We'll figure it out, all right? Don't worry, it's not the end of the life. We'll figure it out, all right? Slowly, you guys are getting to see my actual personality, okay? This is who I am, all right? I'm a joker at the end of the day, all right? So first few days are serious and then jokes. So yeah, we have a switch, which is our core networking device. What is switch's job? Servers connect to the switch. All the devices that you have on the network, they need to be connected to a switch. What is switch job? If I ask you, switch connects the devices together. What does the switch do? It connects the devices together. It enables the devices to communicate with each other. What are the devices? The servers, printers. It enables the devices to communicate with each other. That's the switch job. Straightforward. Okay. Now, I have these three servers connected to this switch through the RJ45 cable. All right, remember this? Another component, networking component that I'm showing you over here, core component, RJ45 cable. RJ45 cable has two ends. One end, this is one end, this is another end. This end will go into the switch right over here. The other end will go into the network card of the other server. So far, so good. All I explained you guys is that if you have devices that you want them to talk to each other, you need a physical switch. And just connect one side of the cable into the switch, the other side into the server's network card. Talking about network card. Is everybody logged into the Linux terminal? Can I talk about the commands that I really want to talk about? Haha. Let's say I want to know on my server how many network cards do I have? All right, so let me go ahead and stop sharing over here for a second, and rather start sharing over here, and I'll give you guys right here the entire screen. Okay, we are logged in. Now I'm going to go to my terminal. May look a little different than your terminal, not a big deal, but this is my terminal over here, and clear command will clear the whatever you see on the screen. It's going to clear that. What do you mean by network? What we're talking about network right now, a physical phenomena. You have physical servers, you have a physical switch, you have physical cables. You want to connect all of these components. Why? Because you want to network them. Network means you are able to communicate with each other. You're able to exchange information. You're able to send some frames or data or packets, over the network. That's how computers talk, through a switch inside the building. And when they want to go outside the building, they use another thing called router. But I want to come back to this. Let me share while I'm teaching you. So if I ask you, the server that you're logged in right now, how do we check how many network cards do we have on that server? The command would be, well, we have multiple commands, okay? But one command, which is the most basic one, is called ifconfig. So I type that command, and I can go up a little bit, and I can see on the left side over here is the name of the card, the name of the interface. Believe it or not, everything has a name. Even in the technology, everything has a name. A tiny thing has a name. Just like your cat has a name, your dog has a name, you have a name, your brother has a name. Everything has a name. So this interface over here, Docker, is something virtual. We're not going to get into that right now. This interface over here is one of the physical network card that looks like this over here on the server that we are connected, and that server is sitting somewhere downstairs in the data center. Okay, so it turns out that it has one network card, it has two network card, it has three network cards, it has four network cards. It has four network cards. Yeah, you're going a little bit advanced level, Abdul, that's okay. But it has four network cards. Is everybody able to identify the network cards, the number of network cards? Through the ifconfig command? Very good. Ifconfig command is 100% going to be on your interview. There is no way you can escape this command. You cannot escape a question on the networking on your interviews. I'm going to start preparing you day one for your interviews. And I'm going to share one story of my student that went to the interview, knocked down the interview. And I'm going to relate it to you guys, how much knowledge you guys have as of today. If you were able to answer that question, if you went in, okay, by just attending 3 sessions over here. Now, 4 interfaces, ladies and gentlemen. I want you to understand one thing. If I go back into my PowerPoint, let me give you another command to see your interfaces. I can also type the command nmcli. Type nmcli, Network Management Command Line Interface. nmcli, Network Management Command Line Interface. So, what do you see over here, ladies and gentlemen? You see connected 1, 2, 3, 4. You see the yeah, so you're seeing the 4 interfaces over here. Exactly what the ifconfig command showed you. So there are multiple commands to do things on Linux, okay? So now we know ifconfig command will give me all the interfaces. So understand this slide over here, folks. You have your server laptop. It gets connected to the switch. What is switch's job? Switch connects your devices to the network and forward the packet to the router. Switch connects devices to the network. Okay. Yes, Faisal, thank you. And then one more piece of the equipment is required. If you are working, let me show you over here. This is our server 1. This is our server 2. And this is our server 3. And what we did is basically we took a cable from server 1, from server 2, from server 3, right? And then we connected that cable to what? To a switch over here, right over here, to this port, to this port, and to this port. Now what do you guys have? This is server 1, this is to server 2, this is server 3, and this is your switch. What is switch doing? Switch is connecting these devices on the network. So you have a network over here. You have a network, working network, ladies and gentlemen. Now, if you want your machine, so you have a network over here. Let's just say there's another building where you have a server, couple of servers, or maybe 200 servers or 500 servers, whatever the scenario is. And then you also connect those servers to a switch. So, this server gets connected to the switch. This is your network. This is network A. This is network B. In order for you, can this network talk to this network? If I am in one building and I have my servers over here, and then downstairs I have 5 servers connected to another switch, can they talk to each other? It doesn't make sense. I mean, I have servers over here. How are they going to talk to each other? I need another thing on the network. I need a router in between over here. And so, ladies and gentlemen, I got myself a router over here. This is not the enterprise grade. This is a home grade router. Okay? And now what I need is basically, I need a cable plugged into this switch on uplink port somewhere, port 1 or port 2. And then I will take this cable. You can make my video bigger. That's in your hands, not in my hands. The view is in your hands. You can make my video bigger and smaller. That's entirely in your hands. And now I plug it into this port over here. And now this router is giving me a network, routable network. Understand? I have servers that are connected to the switch. And then I connected the switch to the router. So now what I have is a network that can reach other devices on other network. Are you guys able to see my video? Somebody saying they're not able to see my video. You are able to see my video, right? Most of you guys are able to see my video. Now, so it turns out a network switch connects the devices, right? So you connect all the devices to the network switch. And then switches get connected to the router. Switches get connected to the router, and that's how you can go from one network to another network. And that router is also called a gateway. That is absolutely right. I have 5 servers sitting downstairs. They are connected to a switch. And I have 3 servers sitting over here, and they are connected to a switch. This is network A, and the downstairs network is network B. Can the network A and B talk without a router? There's no router, by the way. No. So what is happening on network A, which is right over here? I have a switch and I have the servers connected to the switch. Can these servers talk to each other? Can this server talk to this server without a router? Yes, this server can talk to this server. 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 Yes, because they are connected to the switch. As long as you have a switch between servers and they all get connected to the switch, they can talk to each other. So this is one family now. They're talking to each other, right? But as soon as they want to go to a different network, which we have downstairs, 5 servers connected to a different switch, that's a different network. That's a different family. That's a completely separate network. In order for us to talk to that network and that network to talk to us, we need a network router. Right over here, this device. So now, if you understand what I just explained you, what is switch's job and what is router's job? Explain that to me. Switch connects devices, enables them to talk to each other on a particular network. Okay? But if you want that network, so if you want devices to talk to each other on a network, you need a switch. If you want devices to talk to different network, or you want network to talk to a different network, you need a router. So switch connects the devices on a network. A router connects different networks with each other. Network A, network B. Router, talk. Freely talk. There's no router between us. 2 networks cannot talk. These servers connected to a switch, network A. Downstairs, 5 servers connected to a switch, network B. Network A and network B cannot talk to each other. But the devices on network A and on network B can only talk to network A and network B devices. In order for us to enable these 2 networks to talk to each other, we need a router. So ladies and gentlemen, switches, let's do this. Servers connect directly to switches. Servers get connected to switch. And the switch gets connected to the router. That's how it works. All the devices on the network, they get connected to the switch, and the switch only gets connected to the router. That's how you're able to communicate with each other. Let's talk about this. I have a device over here, and I have a device over here, and I have a device over here, and I have a device over here. What do I need in between these devices to talk to each other? You guys are killing it. I need a switch over here. By the way, switches come in different number of ports. The standard port on a enterprise level switch is 48 ports. 48 ports. They have different speeds, ranging from 100 megabits to 1 gig to 10 gig to 100 gigabits per second. 10 gig is mostly acceptable in the enterprise data center grade. 100 gig is there too. So 10, 25, 100, and 100 gig per second. This is what's going on. That's the speed of the switch. So in a nutshell, your devices get connected to the switch. Now, the communication that takes place between this switch, this is very, very important and a new concept that I'm sharing with you. This communication that takes place between the server and the switch, it is based on something called MAC address. MAC address. By the way, so on my server, I have a network card, also called NIC, interface network adapter. And this network card is produced by some manufacturer. It could be by Intel. It could be by give me some names of these manufacturers: Intel, Dell, not AMD. Nvidia do not make network cards. HP, Netgear, not Lincoln, Broadcom, yes, Broadcom, definitely. Broadcom network cards are very, Linux does not make network switches, okay, network cards. And every network card comes with a MAC address. And the MAC address number looks like this, AF colon 8F colon blah 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 7G colon, and let me just show you the network MAC address. So we're gonna find out the MAC address of every single network card in our Linux machine. That's our next task over here. So let's see over here. This guy over here, I'm going to take a snipping tool right over here. And we're going to look at the properties of a network card, and just one network card, and then we will break it down what this is. Okay? Everybody's with me so far? How many of you are saying, this is crazy, this is nonsense, I would never be able to understand this. I can never learn anything like this in my life. I'm sure there's a crybaby out there that's thinking just like this. What is this guy talking about? It's flying over my head right now. God knows I could never learn anything in my life. Well, let me tell you one thing. If you don't learn this goddamn thing, you ain't gonna be able to make $120,000. It's a very simple equation. And I don't know of any other place where you can go learn things in 6 months and get out of that course starting with $120K and going all the way to $176,000. I swear to my God, one of the kid in my class is making $176,000 from batch 2025. It's a different story. He's still deciding whether he wants to take that or if he wants to stay home. So come over here. Learn this because I'm here to teach you and you're going to learn it. All right. This is the name of the interface over here. And it's made by Broadcom. Some genius over here told us the Broadcom makes these network cards. This right over here is his MAC address. So 1, 2, 3, 4, 5, 6. This all makes it a MAC address. What is it that you are showing us right now? It's nmcli. I'm showing you the output of the nmcli. It's a beautiful command to look at your network cards and their associated information. MAC address. Every network card that gets made by the company, Broadcom, Netgear, Cisco makes network cards too. Qualcomm makes chips, not too many network cards. They are responsible to assign every network card a MAC address. MAC address is very important because MAC addresses are used to communicate between the switch. This is just like, just like you guys have Social Security. We are known by our Social Security in our system. You know that, right? Those of you who are living in the United States, every single one of you have a unique Social Security address. Just like that, every network card has a unique number that's unique to that network card. There's an authority, I don't know what that authority is called, IEEE. They give certain numbers of that network MAC address to the manufacturer, and then the remaining numbers manufacturer make sure that it's a unique number in the entire universe assigned to that single network card. You know why? Because the MAC address can track your machine down, where it is, who purchased it. Yeah. When you go online And when you do something crazy, you want to do cyber attack, or your MAC address can literally, authorities know where your IP address is and where your MAC address is, and they can come get you. All right, so MAC address is something that's permanently printed on your network card, and the MAC address, when your server and the switch communicate with each other, they are using MAC address to communicate. Okay? They are using the MAC address to communicate. So at the switch level, the communication happens between the server and the switch using what? Using what? The MAC address. Oh, bolo te sahi. MAC address, guys, say it. Okay? Why you guys are so afraid to tell me something that I want to ask you? Communicate with me, okay? That's how you're going to learn more. All right? So, when your server and your switch is talking to each other, and these machines are talking to each other at the switch level, and they're not talking to a different network, they are using MAC address to communicate. Everybody's good? Are we happy? So what do we know so far? We know that in order to form a network, we need a switch. And all the devices connected to switch. They connect to switch. And then these devices can talk to each other, only each other. But if we want to talk to another family, another network of servers or devices, we need in between a router. We also learned that the switches, the machines that are connected to the switch, they communicate with each other using the MAC address. But as soon as they want to go to the different network, and now the traffic needs to go to the router, the machine will use something called IP address. IP address. Internet protocol address. IP address. So we learned about switch. Switch, all the devices get connected to the switch. The switches get connected to what? Switches get connected to routers. Communication on the network happens because of the switches. Communication across the networks between two different networks happen because of the routers. If I just talked about switch and router without showing you these devices, you would be thinking this guy is the most craziest person. I don't know what the hell he's talking about. Now you're seeing the goddamn switch over here, and you're seeing the router over here. It should make a lot more sense to you. Does it make a lot more sense to you guys? I'm teaching you like I'm teaching a 5-year-old kid. And believe you me, one of my students got an interview with Red Hat company, and they asked her this question: can you explain a concept like you're explaining to a 10-year-old kid? Because the manager wanted to see how you can simplify the terminologies. If you can simplify the technology and terminology, then you understand it inside out. If you cannot simplify it, then you just simply do not understand it. It's not in your system. So the reason I'm able to simplify these technologies and these terminologies is because it's in my system for the last 15 years. Okay. We know what MAC address is. MAC addresses are assigned to what? What MAC addresses are assigned to? They are assigned to network cards, NIC, interfaces, network cards. Okay? And IP address is assigned to what? IP address is assigned to what? They are also assigned to your network card. They are also assigned to your network card. I know you're going to hate me. I know you're going to hate me for this one. So this is the story. Let's talk about this over here. We have a network card, and by the way, Can you identify the network card on this server over here? This is the network card right here where the cable is plugged in, and there's a so the network card has two addresses. It has MAC address and it has an IP address. When it wants to communicate to the switch, it uses the MAC address. When it wants to communicate to the router, it uses what? The IP address. All right, let's take a look at one more time to our nmcli output again, because nmcli and ifconfig, they give me information about my network card. They give me information about my network card. Can we go take a look at this one more time? Let's go. I'm going to type over here one more time. I'm going to say clear my screen and type nmcli. And I'm going to go to the snipping tool, and I'm going to be able to just take these two interfaces, the information of these three interfaces, let's say, right over here. Here. What is Syed Ali doing over here? Let me remove this over here. Let me do this one more time. Let me go to snipping tool. If you understand what switch does, what router does, what is an IP address and what is a MAC address, we are in a win-win situation for today. Okay, you can sleep with peace that you're going to get somewhere. If we do not understand that, then there's a problem. And by the way, I'm going to work on this problem with the connection that you guys are having, and I promise you next time you guys will not have that problem. Okay, we're going to work on this on the back end. The problem is we ran a test for 500 users. It was successful. We put a load on this. It was successful. But when the actual users come, they do crazy things. They put in the wrong password. They will try different things. So you have a lot more fun that way. So come over here. What is this over here all the way? I explained you guys earlier. What is this called over here? What's the name of this? What is this name over here? This is my baby NIC. Okay? Network card, network interface card. And who's the maker of this baby network card? It's a Broadcom. Broadcom company made this network card. And this is the make and model of this. Okay? Now, can you tell me, this is saying over here that this is an Ethernet card. Ethernet card means it will work with the RJ45 cable. It will not work with the fiber. It's not a fiber card. Fiber cards are different. They also bring the traffic inside the server, take the traffic outside. Okay. The reason I'm able to communicate with you over Zoom is because I have a network card in my laptop, which is wireless. And that's why we're able to connect. So now we're looking at the server side. What these network cards do on the server side. Well, it's an Ethernet card. Ethernet cards means it uses the RJ45 cable. It's not a wireless card. It's not a fiber card. It's a Ethernet card. Everybody understand that? Ethernet is a topology. It's a technology. Okay. Let me put it into this port over here. Oh well. Now, this number over here is a MAC address. How can you identify this is a MAC address? There are 6 octets. 1, 2, 3, 4, 5, 6. 6 octets. 6 sections, you can say. And that's how you identify this is a MAC address. Is this MAC address different from this MAC address? Because now I am looking at a different network card over here. We're going to get along if you're listening to me, if you're paying attention to me and not to your goddamn TikTok and social media. That's number 1. Number 2, we're going to get along if you're understanding and you're participating in the chat over here, which is probably maybe 20% of the class right now. So I'm getting along with 20% of the class. 80% of the class is against me. Okay? That's the ratio that I see right now. Okay, good job. Right, so what I know about this network card has a MAC address over here. It's made by Broadcom. It's an Ethernet card, and the IP address is this right over here, ladies and gentlemen. This is the moment of truth. This is when the guard revealed the IP address to the network card. Okay, this is your IP address. This number over here, this number is your IP address. All right, and this is another network card over here. It says connected. That means there's a cable connected. There's a cable connected. Is this too much stuff? Is this like really crazy to understand what I'm teaching you guys over here? I kid you not. I promise you, there are so many system administrators, they don't know how to read this information. I promise you this. All they know is this is the IP address, and that's all they care about. They don't know what MAC address does. Okay, so now, this is such a beautiful thing if you can pick it up. So, IP address. The story of the IP address is this: your life runs on IP address as of today. Your cell phones have IP addresses, your computers have IP addresses, your cars will have IP addresses. Your machines, your refrigerator will have IP addresses. I used to work for this guy. His name is Hossein Aslam Bolchi. You guys can Google him. Big name in the industry. Aslam Bolchi, Hossein Aslam Bolchi. Eslambolchi. He wrote this book in year 2000, I believe. And his book name was Vision 2020. Vision 2020. And he said, by year 2020, everything, IP will eat everything. He was the chief technical officer at AT&T Labs, and I was his executive support main guy working for him in California. And I served this guy for about 3 years, and it was the most beautiful time of my life because I learned a lot from him. Knowingly and unknowingly, I was a young dude. I flew with him on a corporate jet, just me and him, from California to New Jersey. It was a beautiful, you know, I learned a lifestyle, expensive luxury lifestyle from him. So I learned a lot of things from him. And he left AT&T, and then I came back to New Jersey for my job because I had moved to California for my job. Hossein Aslam Bolchi is a smart guy. He's still my friend, and I still talk to him. And I was texting him the other day. I said, Hossein, what do you think about the AI? Think about the AI. And I asked him, and I can share the text with you guys at some point. Smart guy, because these guys are the decision makers. He's the top league. These are the top guys in any company. And a company like AT&T, where you have 300,000 employees, it's like you're running a country on its own. At some point, AT&T was the biggest real estate asset owning company in the United States. I don't know as of today. So I enjoyed working for AT&T. It was excellent work-life balance over there. Enjoyed my time. And so he wrote the book, IP Will Eat Everything. And today, this is where we're living. Your watch, your cell phone, your refrigerator, your homes are running on IP addresses. Your cars are running on IP addresses. Your trucks will be running on IP addresses. And I asked him, what do you think about the AI and the role of the AI in the modern era? And he said, unfortunately, it's going to kill a lot of jobs, especially if you're doing a junior level job, desk job, especially if you're doing anything repetitive. If you're not doing smart work, if you're not a highly skilled person, chances are you're going to lose your job in next 3 years. Chances are everything is going to be automated. But how AI is going to automate working with these guys, servers. The way AI is spreading, you're going to see a lot of, you see, no, you mean digital things, self-driving cars, not manual one. No, your cars are actually running on, software, and they're connected. They're connected to something, and they can be controlled remotely. You know that, right? They can stop your car. They can, do crazy things to your car. Yeah. They're connected all the time to IP address. Anyway, so the coming back to this topic over here, this is the IP address over here. I throw in a lot of stories. If you don't like stories, let me know. I will keep it specific to the topic and no stories at all. And then you have your router over here, default router. This is the IP address of the default router, this guy. Okay. This is the IP address of this guy, the default router. When this machine wants to go talk to this machine on a different network, right? This machine will send the packet through the switch to this router. This router has an IP address. So let me draw this for you over here so you will understand better. This is not an easy topic to understand. Okay, if your understanding is you're doing great. Here, I have a device over here. 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 Device means server. And we have switches. We have a switch over here. And there is a cable going from this switch to this server to this port, this server to this port, this server to this port. This called a network. We have a for AI, we need data centers, and data centers have servers. We are studying how we handle servers. Absolutely, that's right. So this is network A. This machine over here, ladies and gentlemen, has two type of addresses. One is the IP address, the other one is the MAC address. Okay. So when this machine, let's take a look at this. Let's say that this machine wants to talk to this machine. Will it use the IP address or MAC address according to the information that I gave you? It will use the MAC address because switch on the same network will only use the MAC address. Okay. Why? Because it doesn't have to hit the router. Router is all the way over here. It is also connected to the switch. Okay. Now let's take a look at another picture over here. Let's say I have a network over here, a network. The network has this device, server, and there is a switch in between, and it has some ports. And now we have another network over here, another servers over here, bunch of servers over here, and there's another switch over here on this network. And now, ladies and gentlemen, all of a sudden, this server, this guy wants to talk to this guy. So what do we need in between? In order for these two guys to talk to each other? We need to bring in something called a router. So the switch gets connected to the router gets connected to the another router, and this router gets connected to the switch. Okay? Now, this guy wants to talk to this guy, and will it use the IP address or will it use the MAC address? This time it's going to use the IP address because now the story is leaving this network. Okay, this packet wants to leave this network and hit the router. And what language router understand? Does router understand the MAC addresses or IP addresses? IP addresses. IP addresses. So once again, what is the switch job? What does the switch do? You connect devices to the switch. Switch connects devices. And what is router's job? Router connects networks. Router connects networks. Switches get connected to the router. If I am on a network and I want to talk to machines on my network, the communication takes place via MAC address. If I want to communicate to a different network, my machine wants to send a packet to a different network, my machine will have to contact the router. It will go through the router. And the router has an IP address. Therefore, my machine will use the IP address to connect with this router. Router is the middle guy. What is a packet? Somebody says packet is when two machines want to talk to each other, like my machine and your machine is talking at the back end. So how they are talking? Just like I'm throwing words at you, machines send packets. They divide the data into small packets. So my picture, my talk, my voice is divided into small packets of data. And then my system is transmitting that data. My system is transmitting that data. Okay? So now we're not going to cover IPv4 or IPv6 right now. Right now, this is just a simple understanding. So now, are you guys with me so far? So therefore, my network card has what? Let's talk about this. My network card has to have what, ladies and gentlemen? My network card has to have MAC address. It has to have an IP address. And it has to know my default route. Ladies and gentlemen, the default route is the IP address of my router. IP of my router. Also called gateway. Also called gateway. Let me give you a scenario over here. Right over here. I have 3 guys sitting with me over here in this room. Okay? I have 3 guys sitting over here with me in this room. And I want to talk to them. I am simply going to yell at one of these guys and I'm going to start communicating. They're cute guys, by the way. They're very cute guys, okay? They're a little bit confused, but cute guys. Anyway, so I'm over here in one room and I have these 3 gentlemen that I want to have a conversation with. All I'm going to say is, hey, Khizr bhai, how are you? And he's going to respond back to me. Now, another scenario. Right outside of this room, and my next door neighbor, John, lives in a separate home. And I want to talk to John. Can I simply yell at John and he'll be able to hear me if it's very next door neighbor? But I highly doubt it. So what do I need to do? If you're living in smelly New York and smelly Brooklyn, where you smell the garbage trash every night from your apartment, then yes, it is possible. You can yell at your neighbor John and he will yell back at you. But if you live in a beautiful state like New Jersey, this is not possible. Okay. So I want to talk to John over here, which is my neighbor. So what do I need to do? I need to exit out of my gate and get out and then go to his gate and enter, and then I can have a talk with him. Okay. And so this is gate. And same thing applies to the network. Same thing applies to the network. I have a machine over here, machine over here, machine over here, machine over here. I got to switch in between. Now I don't have that liberty to yell at somebody. I have to go and go through switch if I want to talk to each other. But there is a gateway on my network. There is a gateway on my network. There is a gateway that brings the traffic in and out of my network. And that gateway is called router. So now, if John's machine, I want to talk to John's machine, which is on a different network, by the way, and John wants to talk to my machine, so what is John going to do? John also has a switch over here, and he has different machines, and they're all connected to the switch. By the way, this switch is also connected to a different router, and that router gets connected to my router. Yes, the router gets connected to the switch at the end of the day. Routers can connect with each other, but a switch has all the devices and there's a router connected. And this router has to connect to the next router's network. The next router's network has to connect to the next router's network. And then coming on Saturday, I'm going to show you how many routers it takes you to get your dopamine daily when you get that social media dopamine. How many networks your packets go through before you hit that Instagram, or before you hit that Facebook page, or before you hit that TikTok. How many networks your packet has to go through? We're going to cover this in next Saturday class. And we're going to cover how the traffic goes from one network to another network. But for now, I want you to tell me what are the most important elements that are, what are most important things that your network card has to know. So a NIC has to know what? Let's talk about this over here. A NIC has to have an IP address. A NIC has to have a MAC address. A NIC has to know its default gateway. That's the right term, ladies and gentlemen. Default gateway, which is basically the router IP address. If you have these three things, your machine is on the network. Your machine is on the network if you have these three things. And obviously, the cable has to be connected to the switch and to the machine. So let's see real quick over here. In my snipping tool over here, let's see. Does this network card have a MAC address? Yeah. Does this network card has an IP address? Yeah. Does this network card has the default gateway? No, right over here. Default gateway. Default gateway. Default. Look for the default. Default gateway right over here. Beautifly. How do I know? How do I know if my machine is online or not? Let's take a look at this. If I know the IP address of my default gateway, I can use the, now, you know what? It's too much for today. I was going to give you another command to check the connectivity. Oh, there you go. Saba knows the answer. What do you guys think? Next command, to know the connectivity between two machines. That's your homework. That's your homework. For homework, I want you to find out who assigns the MAC address to the network card. Three questions I'm going to give you. Who assigns the MAC address to your network card? Where do IP addresses come from? Like our parents told us, the babies come from sky. They told us this lie. Babies come from sky. Do IP addresses also come from sky? That's the one thing I want you to find out. Do IP addresses come from sky? That's another thing I want you to find out. Another thing, how is it machines have IP addresses, network cards have IP addresses, yet we can use English letters like google.com, instagram.com. How is it possible? How does it work? Yes, Abdul, you're right. How do we translate the name, English name, into the IP address? Beautiful. So these are some of the questions for you, and I'm going to stop my lecture over here.